Have you ever looked at student data and seen something that just doesn't add up? You see students absolutely master a skill in one problem, but then they completely miss it on another one that's supposed to be testing the same thing. It's a puzzle we see all the time in 6th grade math. Well, today, we're going to crack that code. We'll use real state test data to figure out exactly where students are stumbling and, more importantly, how we can help them soar. Okay, so let's get right into the heart of this mystery. I'm going to show you two problems. And look, on the surface, they seem to be testing the exact same skill. But the student outcomes, they couldn't be more different. And this, right here, is where the data starts to tell a really fascinating story.
So, let's start with a big win. Check this out. This is a problem where more than 3/4 of our students just aced it. So what was the secret sauce? What made this one so straightforward for them?
It's all about the context, right? 4 friends splitting the cost of museum tickets. That's something they can actually picture. It's relatable, it's concrete. The math here is simply dividing money, which is a skill most students are pretty comfortable with. They see a total cost, they see the number of people, and the path to the right answer is just crystal clear.
77%. That's huge. That is a really solid success rate. And what this number tells us, loud and clear, is that our students can do division with decimals. They've got the skill, but hold that thought, because this story is about to take a very, very sharp turn.
Okay, so if we know for a fact they have the skill, what on earth happens here? Why does their performance just totally tank on a different problem? We go from 77% success all the way down to just 37%. We're talking a 40-point drop. That's massive. So what's the variable? Let's take a look.
And here it is. This is the problem that's causing all the trouble. So instead of friends and money, now we're in a science class. We've got a chemistry teacher, 18 boxes of baking soda, and each student needs 2/3 of a box. The core math is still division, but we've swapped out those friendly decimals for a tricky fraction. And we traded a familiar scenario for one that's a bit more abstract.
And boom, look at that result. Only 37% got it right. So get this, it's not the division itself that's the problem. It's the type of number, the fraction, and the whole context of the question that's throwing them for a loop. Let's break down exactly why.
Okay, so let's really decode this. We're going to zoom in on a specific Texas Educational Standard, TEKS 6.3e, to really peel back the layers on this division dilemma and find the absolute root of the error. So here's the standard we're talking about. And you see that keyword right there, fluently? The data is practically screaming at us that students are fluent with some rational numbers, like decimals when we're talking about money, but that fluency just disappears when it comes to fractions.
Okay, so here's the #1 mistake we see with that baking soda problem. It's so common. Students see the numbers 18 and 2/3, and their brain just defaults to multiplication. They get 12. They see that phrase 2/3 of a box, and they think multiply, but they're totally missing what the question is really asking. They need to be dividing the total supply, 18, into these smaller groups of 2/3, and when you do that, you get the right answer, 27.
And this, right here, brings us to the solution. And it's so powerful. It's all about the language we use. If we can teach them to reframe the problem in their heads, to actually ask themselves, how many groups of 2/3 can I make from 18, suddenly it clicks. The need for division becomes totally obvious.
And you know what? This exact same pattern, it's not just a division thing. We see the exact same story play out with another standard, TEKS 6.7d, which is all about equivalent expressions and the distributive property. Students crush the simple problems, and then they fall into this super predictable trap when things get just a little more complex.
Just look at this. It is night and day. On the left, you've got a simple problem about reordering terms. 79% of students got it right. They get it. They see 6 times p plus 3 is the same as 3 plus b times 6. Easy. But then you look at the problem on the right, a distributive property problem, and whoa, the success rate just craters to 23%.
And the thing is, the mistakes they're making are so predictable. The biggest one, by far, they don't distribute to every term inside the parentheses. They'll multiply the first number and then just leave the second one hanging. Sign errors are another huge one, especially when you throw subtraction in there. It's a classic trap.
Okay, so we've diagnosed the problem, we've seen the symptoms, so what's the cure? Well, it really comes down to one big idea. We have to move our students from these abstract concepts to concrete visual strategies, things they can actually see and touch and manipulate.
Because let's be real, this is what we're up against. On the state tests, our kids are looking at these abstract algebraic expressions, a lot of times with big, scary numbers. Is it any wonder they get overwhelmed and start making mistakes?
I mean, look at this monster. 38 times the quantity of 251m minus 45. To a sixth grader, that's not math, that's just a jumble of symbols. And the data shows it, only 19% of students got this right. We have got to make this real for them.
So, what's the fix? How do we do that? Well, the single most effective strategy is using concrete area models. We have to introduce the distributive property with these models way before they ever see the abstract algebra.
And this is a perfect example from one of the district assessments. It's beautiful. Students can physically see the rectangle. It's got a height of 5, and the length is broken up into 2 chunks, a 5 and a 7. They can see that the whole area, 5 times 5 plus 7, is the exact same as adding up the 2 smaller areas, 5 times 5 plus 5 times 7. This visual just makes the whole property click. It becomes intuitive.
All right, so let's pull all of this together. How do we make this happen in our classrooms? Let's boil it down to a clear 4-step action plan you can literally start using tomorrow.
Okay, here it is. Number 1, area models are now your best friend for the distributive property. Use them all the time. Number 2, get everyone using that consistent language for fraction division. How many groups of? It works. Number 3, start creating your own practice problems that look and feel just like the ones on the state test. And finally, number 4, use those district-level questions for quick, regular checks. Don't wait for the big test to see if they get it.
So I'm going to leave you with this thought. The data doesn't lie. These student errors, they're not random. They are predictable patterns. And once we see the patterns, we can turn those moments of total confusion into these amazing light bulb moments. So my question for you is, what predictable error are you going to turn into a light bulb moment in your classroom tomorrow?